Okay kids, now we'll be going with this center of mass discussion. Yeah. So you can try the first question. The first question says like sand drops vertically from a negligible height at rate sigma kg per second onto moving conveyor belt. Now they are asking so many questions like what must be the force you need to apply so that it can move with a constant speed v. Thereafter, at what rate the kinetic energy is increasing with per unit time. Thereafter, like work done by you per unit time. Thereafter, how much energy is lost as heat. So I'll be doing all those here. Now let me say the cart has mass m at certain moment. I mean I'm taking some generalized moment where cart plus some sand, that mass is m, and now some small mass of sand will be falling into it. Now they said like the constraint is it needs to move with constant speed, so for that you need to apply some force. We will see why we need to apply some force. Now this is the initial situation where the cart is going. Now this sand is going to drop. Now before dropping its horizontal velocity is 0, right? Now after dropping, what will be the situation? The total mass will become m plus dm, but it has to move with constant speed. For that we are applying some force, so constant speed. Now we will see what is the change in momentum for final case and to initial case. So in the final case, momentum is m plus dm into v. In the initial case, momentum is m into v. So what is the change in momentum? Change in momentum is final momentum minus initial momentum. So this is small change in momentum during that small time interval. So which will turn out to be how much? M into v will get cancelled. So you will be getting dm into v. So what is the rate of change of momentum? That is dm by dt into v. Dm by dt is sigma given in the question. So this is the force we need to apply to make it move with constant speed v. Now what is the work done by you per unit time, or what is the power you are giving, right? So that is F into F dot V, that is sigma V square. So that is the rate at which you are doing work, or that is the power. So these are two questions that they asked in the earlier one. Now what is the change in kinetic energy? During this instant, what is the change in kinetic energy? That is final kinetic energy minus initial kinetic energy. Final kinetic energy is half into total mass into v square. Initial kinetic energy is half into m into v square. So what is the change? Half mv square will get cancelled. So you will be getting half into dm into v square. So that is a small change in kinetic energy. So the rate at which kinetic energy is changing is half into dm by dt into v square, which is half sigma v square. So the rate at which kinetic energy is varying is half sigma v square. We are giving this much power, but out of this only half of it is going as increment in kinetic energy. The rate at which kinetic energy is increasing. So basically we know by energy conservation, whatever work done, that must be either increasing kinetic energy or heat developed in this particular case. So there are only two ways for us right now. So either it must increase kinetic energy or it must dissipate heat. So the rate at which we are doing work, that must be either converting as the rate at which kinetic energy is increasing or the rate at which heat is getting dissipated, right? This is sigma v square we calculated, this is half sigma v square we calculated. So the leftover will turn out to be half sigma v square. So that is out of sigma v square power we are giving, half is getting converted as incremental in kinetic energy per unit time, remaining half is going as heat dissipated per unit time, right? So sand is dropping, so from velocity 0 suddenly it is becoming velocity v. When some things are changing suddenly, then there will be some heat dissipated, right? So that's inelastic collision. In inelastic collision, you can see like its velocity is 0, just after hitting its velocity is becoming v. So it's kind of inelastic. You know, in inelastic collision there will be heat dissipated, right? Now going to the next part of the question. So that is this question we did. It's the same as this question also. Both are same questions. Now the other part of the question, in this particular question what they are saying, now consider a case in this manner, consider a case. But what they are saying, there is a car with sand. Now sand is getting leaked. Now how much force you need to apply? So previous question was there was some belt going and sand is getting dropped. So what force you need to apply so that it will move with constant velocity? That was previous question. Now the new question is there is a cart with sand and sand is leaking. A cart is moving with velocity v, sand is leaking. So what force you need to apply to make it move with constant velocity v? So that's the question. Now if I try to draw the figure, now I'll be assuming this as mass of cart plus sand at certain moment and its velocity is v. Now some mass is getting dropped, some sand is getting dropped. So now the important thing is sand which is going to get dropped is also having initial velocity v in this direction. So after getting dropped also it will have the same velocity because of inertia, right? So after dropping also its velocity will be v only. So the remaining has to be a minus dm into v because we are maintaining it. So in order to maintain that, do we need to apply any force? We will see. So we will see, is there any change in momentum happening? If there is any change in momentum happening, I need to apply some force. So change in momentum is final momentum minus initial momentum. That you can see easily, you don't have to write this one, that you can see clearly. Total final momentum is same as initial momentum, that is there is no momentum change happening, so you don't have to do anything to make it move with constant speed, right? So the force you need to apply is 0. So even though sand is dropping, this speed won't change because there is no change in momentum, right? So basically this is not applying any force on this is not applying any force on this. Now going to the next question. A pulley fixed to the ceiling carries a thread with bodies masses of masses m1 and m2 attached to its ends. The mass of the pulley and thread are negligible, friction is absent, find the acceleration of center of mass of the system. Now this figure you must have seen in Newton's laws. I have taken it, so I don't have to explain this. I consider for a case where m2 is greater than m1, so this will be going downwards, this will be going upwards. F equal to ma for this block, F equal to ma for this block. When I solve them, I will be getting acceleration as this much, tension as this much, 2t as this much, that is this. Now if I take this thing as my system, how many forces are acting on my system? Now all these are internal forces, so the only external forces are this 2t and m1g and m2g. So the net force is m1 plus m2 into g minus 2t. So acceleration of center of mass. So let me first of all find acceleration of center of mass. Now m2 mass is greater, I said, so m2 into a will be greater than m1 into a. So obviously center of mass will be accelerating downwards. Now how to find that acceleration? m1 a1 bar plus m2 a2 bar by m1 plus m2. When you do that and when you substitute acceleration value, you will be getting acceleration of center of mass is this much, and in which direction? And in the downward direction. Acceleration of center of mass is this much in downward direction. Now let us see whether we got the answer correct or not. Now what is the net force? Net force is m1 plus m2 into g minus 2t. That's what I said here, right? So if I take this as my system, the net force is m1g plus m2g minus 2t. So that is the net force. Now I kept it as it is. Now tension is 2m1 m2 by, right, or else 2t is this much. You can directly substitute it back, and when you modify it, you will be getting this equation. What is this equation? This equation says total mass into this is acceleration of center of mass. Yes, we know net force on the system must be equal to total mass times acceleration of center of mass. So whatever we have done is right. Now the next question: a raft of mass m with a man of mass m stays motionless on a surface of a lake when the man moves by distance L dash relative to the raft and stuff. Okay, anyway, you can solve the question. So basically the question goes like, there is some raft of mass m and there is some man of mass small m. Now this question must have been done in your class. If the length of the raft is L, now by the time man moves to the other end of the raft must have traveled how much distance back? So this is the question. Now for that you need to understand that there is no friction between this water and the raft, because if there is friction there will be external force, so it will become so complicated. Now if there is no friction, if I take these two things as my system, if I take man and raft as my system, then there is no external force on my system in the horizontal direction. If there is no external force in horizontal direction, then their acceleration of center of mass in horizontal direction is 0. Now the first thing is, there is no external force in the horizontal direction. First thing, I decided my system. My system is raft plus man. Now on my system there is no net horizontal force, external horizontal force. So if there is no external horizontal force, acceleration of center of mass along horizontal will be 0. Now if acceleration of center of mass is 0 along horizontal, its velocity will remain same, which is 0 initially. Now what does that mean? Center of mass, acceleration is 0, velocity is also 0, and center of mass won't be moving. Center of mass will be stationary. Now you know total mass into position vector of center of mass will be given by m1 r1 bar plus m2 r2 bar. So m1 into change in rc bar will be m1 into change in r1 bar plus m2 into change in r2 bar. But what is change in rc bar in this particular question? It is 0. What is the reason? There is no external horizontal force, so acceleration of center of mass is 0. So velocity must remain constant, which was 0 initially. So center of mass will be stationary. So there won't be any change in position of center of mass. So the meaning is m1 delta r1 bar plus m2 delta r2 bar must be equal to 0. Now if I draw the new figure, like let me say the man went here, so by that time you must be knowing, like if the man is going forward, force on him is in the forward direction, so force on the boat will be in the backward direction, so boat will try to go back. So this is the approximate figure I can draw. Now I assumed boat has moved by distance x, so man has moved how much distance forward? It is L minus x. Now according to this equation, now let me say this is man has moved how much distance? M into L minus x along positive direction. Now how much this one has moved? How much the raft has moved? M into x in the negative direction, m into minus x. This summation has to be 0. From there x equal to small m into L by small m plus capital M. Right? Now I will be generally solving it in the other way. It is like how I will be visualizing it is, let me say this is the boat and this is the raft and this is the man. Now this is the case. Now I will be visualizing it in two parts. What are those two parts? I will be assuming like this entire thing is going backward by distance x. This entire thing is going backward by distance x and man is moving by distance L. So what was happening actually, when man was moving, the boat is moving backwards. But when two things are moving, it is difficult for me to concentrate. So what I will be doing is, I will be seeing it like the entire thing is moving back by distance x and the man is moving by forward distance L. So here total m is total m into x. Total m into x is m plus m into x in the backward direction. Now in this particular case, when he is going from here to here, it is small m into L in the forward direction. But what you know, the summation has to be 0. That's what you have seen, right? When center of mass is not moving, m1 x1 plus m2 x2 must be 0 vector wise, or total m into x in this direction movement must be equal to total m into x in this direction. So I'll be equating these two. I'll be getting the direct result. Anyway, so this is comfortable for me, but I think for most of the people it may not make sense. So whatever, if you are comfortable with it, you just follow it, or else there is a traditional method anyway. Now going to the next part. So this was E equal to 0. The meaning is inelastic collision, and yeah, why I have taken this is like some people generally I have seen like facing difficulty with remembering the definition of or coefficient of restriction. It is velocity of separation by velocity of approach, or velocity of approach by velocity of separation. So I feel this is the easy way for you to recollect it back even if you miss during some exam. It's like if you are dropping some ball, then when it is coming closer, it will increase its speed because potential energy is getting dropped, so kinetic energy will be increasing. So just before collision, the speed will turn out to be root of 2gh, but anyway that doesn't matter for me. So just before collision. But you know, when it is inelastic collision, they'll be sticking, or like it won't be bouncing back, right? So its speed will become 0 finally. So E equal to 0, you know. So how you will be getting 0? Whether velocity of separation by velocity of approach, or velocity of approach by velocity of separation. Now what is the velocity of approach here? It is v, right? Just before hitting, this is stationary, this is moving with speed v. Now just after collision, it is becoming stationary, right? So velocity of approach is v, velocity of separation is 0. Now you know, if you want to get 0, you have to divide this by this. That is velocity of separation by velocity of approach. Anyway, I know this is not a good question to take here, but okay, if someone asks you like there was collision between this block, this mass and this earth, it had momentum earlier, but why the momentum became 0? How the momentum changed? So for that, the answer is going to be, if this is the case you are talking about, if there is a small block and if there is earth, and if it is coming and hitting, then obviously the entire system will be having some momentum which is almost negligible because the mass of the earth will be very large. So we are not going to put that negligible velocity, we are saying it like it is 0. So momentum conservation will be valid there. Now going to the next part of the question. Now assume it is elastic collision, that is coefficient of restitution is 1, that is velocity of separation by velocity of approach equal to 1, or in elastic collision, velocity of approach equal to velocity of separation, right? Now this is the given question. Now there is a man who is observing from tree, like ground, from ground. Now there is a huge wall which is moving, some huge object, huge mass which is moving with speed 2, and there is some small mass which is coming with speed 1, which is coming with some speed 1. Now I'll be like going in step by step. Now I will shift myself from this frame to this frame, wall frame. So I'll go from tree frame to wall frame. Then it looks like this. So when I observe from wall frame, all the other bodies will have extra velocity 2. That is, I will feel this is at rest. 2 minus 2 is 0. So when I put it together, then I will be feeling this is at rest, but this is tree is having velocity 2 and this is having velocity 3. Right? Now, what is the velocity of approach with respect to me? It is 3. So after collision, what must be the velocity of separation? It must be 3. So velocity of approach is 3. So velocity of separation also must be 3. Now this is from wall frame, but what I need to from ground frame. So I will shift back myself to ground frame. So when I shift back myself to ground frame, I need to add velocity 2 to every object because tree has to be at rest, right? So when I add all velocity 2 to all the objects, then it will look like this. Speed of the wall is 2, but speed of the ball is 5. Now, what is the velocity of separation between them? You can clearly see the velocity of separation is 3. This is moving with 5, this is moving with 2. So, this is moving with 5, this is moving with 2. So, the velocity of separation is 5 minus 2, which is 3, right? So, velocity of separation is 3. Velocity of approach is 3. Yes, whatever we have done is right. Velocity of approach equal to velocity of separation, right. Now, okay, so you need to take some things for granted here. So let me say what all things were given. Now there is a body of mass 2 kg whose speed is 15 and it is going to collide head on with 4 kg mass whose speed is 6. Now after collision they are moving together with a speed 9. This is also given. This is also given. Now what you need to do is you need to check whether this can happen or not. This can happen or not. Now what is this momentum? 15 into 2 into 15, 30. This is 24. So totally 54. So 6 into 9, 54. So momentum is getting conserved. So that can happen. Now what is the... Okay. Now similarly for the next one also, the initial conditions are remaining same. Final conditions are this is going with speed 3 and this is going with 12. Now whether that can happen or not, initial 30 plus 24, initial momentum is 54, final momentum is 6 plus 48, which is 54. So this also can happen. Now going to the third example, 15, 6 it is remaining same, so total momentum is 54. This is 14 plus 40, 54. Yes, this can also happen. This can also happen. Now I will be going to the first example again. Now what is the velocity of approach? What is the velocity of approach? It is, this is moving with 15, this is moving with 6. So when you observe from this body feels like, you will feel this body is coming with a speed 9. So velocity of approach is 9. What is velocity of separation? Velocity of separation is 0, right? Because this is moving with 9, this is moving with 9. So velocity of separation is 0. Velocity of separation is 0. Velocity of approach is 9. So what is coefficient of restitution? It is 0. Yes, you know in perfectly inelastic they will be moving together, right? Now going to the next example, velocity of approach is 9. Velocity of separation is again 9. So coefficient of restitution is 1 because velocity of separation is equal to velocity of approach, right? Now in the next example, velocity of approach is 9 only. Velocity of separation is 10 minus 7, which is 3. So 3 by 9 is 1 by 3. So coefficient of restitution is 1 by 3 in the third example, right? Now we will see all these three cases from different frame. Now still now we observed from ground frame. Now I will go on to a frame which is moving with constant velocity 9. So if I observe all three cases from a frame which is moving with velocity 9, how it looks is this way. Now if I observe from a frame which is moving with the speed 9, all the bodies will have extra speed 9 in this direction. That is, I will feel this is at rest and I will feel the net velocity of this body is 3, the net velocity of this body is 6. So this blue color things are in ground frame. Now when I observe from this frame, I will be getting extra velocity 9. So finally I will be feeling this thing is moving with speed 6, this thing is moving with speed 3, this total is at rest. Now similarly, I will be going to the next part also. I will be doing the same thing. Subtracting 9. Okay, this thing will remain same. Now, I will be feeling like 2 is moving with the speed 6, 4 is moving with the speed 3. 12 minus 9, 9 minus 3. Now, in the third case, I will be feeling this is moving with the speed 2, this is moving with the speed 1. Now, the important thing what you need to notice here is, this momentum is 12 right now. This momentum is also 12. So net momentum is 0. Initial momentum is 0. So final momentum is also 0. Yes, momentum conservation has to be valid because we are not going to non-inertial frame. We are still staying in inertial frame. That is a frame which is moving with some constant velocity. Now in the second example, again momentum, initial momentum is 0 only. Is the final momentum 0? 4 into 3, 12, 2 into 6, 12. Yes, final momentum is also 0. Now what about this one? Momentum, initial momentum is 0, final momentum is 2 into 2, 4, 4 into 1, 4. So final momentum is also 0. Yes, momentum conservation has to be valid in this frame also, that we know, and we didn't do any mistake. We have seen, like, we have cross checked. Now I'll be trying to find coefficient of restitution from this frame. In this frame, what is the velocity of separation? It is 0. What is the velocity of approach? 6 plus 3, 9. So 0 by 9, which is 0, which is same as what we got earlier. Yes, coefficient of restitution must not depend on frame, right? Now the next thing, velocity of approach is 9, velocity of separation is 9, 3 and 6. So coefficient of restitution is velocity of separation by velocity of approach, which is 1. Now in the next example, velocity of approach is 9, velocity of separation is 3. So coefficient of restitution is 1 by 3, which is the same value what we got when we observed from ground frame, right? Now what we have done, we have taken 3 cases. We observed from ground frame, we observed in center of mass frame, especially from momentum point of view and coefficient of restitution point of view. Now we will see, like, what will happen to the kinetic energy. Now from ground frame, I will see from ground frame. So this is the first example where coefficient of restitution is 0. So what was the kinetic energy of this one? It is this much. Kinetic energy of this one is this much. When you add, you will be getting 297. I am not much bothered about the value. Now final kinetic energy will turn out to be 243. When I see the separation in kinetic energy, that is 54. So that is going to be either heat loss, generally we will say. So let me call it as heat loss. So 54 units is the heat loss here. Now in the next case, initial kinetic energy is 297. Final kinetic energy, when you add these two, you will be getting 297. That is, there is no heat energy loss, which you must be expecting, because E equal to 1 refers to elastic collision where there won't be any mechanical energy loss, or there won't be change in kinetic energy initially and finally. But during collision, there will be deformation. During collision, some of the kinetic energy will get converted to potential energy, but after collision, again that potential energy will be converted back to kinetic energy. So before and after collision, kinetic energy will be remaining same, but not during the collision in elastic collision. Now in the third case, initial energy is this much, final energy is this much, the loss is 48. Now out of all these cases, I have discussed only 3, but out of these 3, which is in which case there is more loss in kinetic energy, this case. But is it the only maximum case, or there can be any other case? That you can't see it clearly from this frame, so we'll try to observe from some other frame. What is that frame? That frame is the frame which is moving with speed 9. So in this particular frame, I will be feeling this velocity is 6 and this velocity is 3. This velocity is 0. So what is the kinetic energy? 54. So I will be feeling this kinetic energy is 54. But what about the kinetic energies after collision? This kinetic energy when I add, I will be getting 54, and this one is 6. So what is the loss here? Loss here is 54. Loss here is 0. Yes, we know. Loss here is 48. Now you can see this loss was same in the earlier case also. If you see here, it is 54, 0 and 48. Here also it is 54, 0 and 48, because heat energy doesn't depend on the frame, right? So heat loss must be same in both the cases. Yes. Now in this frame, you can clearly see what is the initial kinetic energy? 54. Now how much maximum loss can happen? That is 54. So this is the case where maximum kinetic energy loss can happen. That is when E equal to 0. That is in elastic collision, the kinetic energy loss is maximum. Right? Okay. Yeah. So the important things to note here is why I have taken a frame which is moving with speed 9. Why I started observing from a frame which is moving with speed 9. Now the reason is I found the velocity of center of mass. Now what is the velocity of center of mass? This is momentum is 30 plus 24, 54, 54 by 6, which is 9. So velocity of center of mass is 9. So I started observing from a frame which is moving with a speed 9, or the other way of saying this, I started observing from center of mass frame. In center of mass frame, the momentum of the system must be 0. Momentum of the system must be 0, that you can see. So that is one important property of center of mass. From center of mass frame, momentum of the system turns out to be 0. This is simple two-body collision case, but no matter how many masses are there, still from center of mass frame, net momentum has to be 0. And yeah, one more thing you can see here. When you observe from center of mass frame, how perfectly inelastic collision will look like. How perfectly inelastic collision will look like. It looks like something is coming from this side, something is coming from this side, they will be hitting and they will be just stopping. Right? This is coming with speed 6, this is coming with speed 3, they will be just colliding and they will be stopping. But it won't look that attractive from ground frame. Yeah, that's fine. I think from ground frame also it looks some way or the other way attractive, like they'll be moving together. But in this particular case, it's like this is coming with some momentum, this is coming with equal but opposite momentum. You can see 12. So both will be having same momentum but in the opposite direction. So they will be colliding and they will be getting stopped. So whatever kinetic energy was there, after collision it will be converted as heat. Right? Now there is some interesting thing which you can't observe much from ground frame, that is elastic collision. In elastic collision, this momentum is 12, this momentum is 12. Yes, you can expect that because the net momentum has to be 0. But you can notice here the speed is 6 and the speed is 3. Now after collision, this speed is remaining same, but it is changing in the direction. So in elastic collision, what will happen is they will just come with some velocities and they will just reverse their velocities and they will go back. That you can see here. This is coming with 6, this is coming with 3. So 6 and 3, they will be colliding and this will become 6 and this will become 3. 6 and 3. So that happens everywhere. It's not like it happened only in this question. I just took numbers so that you will understand it better. Now I can solve the same thing without numbers, but that will be confusing you. I think that's how the books will be writing, and I think that's the reason you will be getting confused. Yeah, anyway, you can think about that from by yourself. So center of mass frame. Actually, center of mass chapter is not about calculation of position of center of mass. Center of mass chapter is more about center of mass frame and its importance. Now, okay, this question is a easy question only. There are n balls lying at rest on frictionless table with separation between them. This you can try. So the only reason I have put this question is energy conservation, mechanical energy conservation won't be getting valid because during collision there will be loss in kinetic energy. Now I have seen many people asking me this regular question, like there will be some pendulum or bob hanging from a string. Now some other mass will be coming and hitting this bob. Till what height it will be going? So this is the question. Generally what people will be doing is they will be equating the initial kinetic energy of the point mass to the final potential energy of the total thing. But that's not true, because during collision with the bob, it is going to be perfectly inelastic collision. In perfectly inelastic collision, there will be kinetic energy loss. So you can't use that initial kinetic energy as fully converted to potential energy because something is going as heat. So what you need to do is, after collision, whatever is the kinetic energy available, that will be going as potential energy, right? Now going to the next question. The next question says like, n identical balls are constrained to move in one dimension. If you are allowed to pick their initial velocities, what is the maximum number of collisions you can arrange for balls to have among themselves? Assume the collisions are elastic. Now the important thing here is, all the masses are equal masses and elastic collision head on. Now you people must be remembering this well known result. If equal masses collide head on elastic collision, what will happen? They will interchange their velocities. Now that's the only thing needed to solve this question. Now yeah, I'll be giving you PDF, right? So you can read the solution by yourself, but for that what you need to understand is, I have taken 3 balls here of different colors: red color ball, green color and black color. I don't know how they will be visible in video, but this is going to be, whatever R I have kept, that is going to be red. Now what I am going to do is I am just assuming like there is a collision happening between these two. If there is collision happening between these two, what will happen? They will interchange their velocities. So this will be getting g velocity, this will be getting r velocity. Now in the next moment I am assuming these two will be colliding and they will be interchanging their velocities. So this will be becoming r, this will be becoming b. Now this is how it looks. This is how it looks when they are interchanging only velocities. Now I will try to see the same thing how it looks when they will interchange their velocities as well as colors. When they will interchange velocities as well as colors. Here if you see, they interchanged only velocities. Now I will try to draw the same figure by assuming they will interchange their velocities and their respective colors. So it looks like this. These two will collide and this ball is going to get speed r and color also r. So it looks like this. Now these two will collide and this is going to get red color and speed r, right? So during first collision this is going to become red and speed r, this is going to become green and speed g. Now during second collision this is going to get speed r and color red, this is going to get speed b and color black. Now if you observe all these figures, you can see the situation looks like the red color ball is just passing through this green color ball and this black color ball. Now if this red color ball has passed through this green color, it looks like this situation. If that red color ball has passed through this black color, it looks like this situation. So you can visualize this particular situation, that is equal masses colliding head-on elastic collision. You can visualize that situation like one ball passing through the other, one ball passing through the other without being affected by the remaining balls. Now based on this logic, you can see if there are three balls, how to make the collisions maximum. You need to give very high speed to this, little less to this, little less to this. The same logic will apply for n number of balls also. I mean, this is the regular thing we will be doing. If someone asks you to do for n masses, we will check for one mass, n equal to 1, n equal to 2, n equal to 3, and we will try to understand. If we don't know how to do for n masses, at least we try to see for 2 masses, 3 masses and try to understand what is happening, so that we can extend it to n masses. So if I give very high speed to this and little less to this, little less to this, this will be passing through these 2 balls and this will be passing through this 1 ball. So similarly you can apply the same thing for n balls. So if there are n balls, this will pass through n minus 1 balls, this will pass through n minus 2 balls, this will pass through n minus 3 balls. So it will be sum to n numbers, something like that, right? So the next question goes like, a stream of n clay balls with mass m move with speed v in a line across frictionless table. The spacing between them is L, an additional ball. Now there are n balls and this is one more extra, so totally n plus 1 balls are there. An additional ball m sits at rest in front of them. The front ball moves and collides with stationary ball and sticks to it to form a blob of mass 2m. The second ball collides with blob and becomes 3m and so on. How much time elapses between instant shown below between the last collision? So you need to solve from this from lab frame and from the frame where n balls are at rest. So that I'll be doing. So I'll be doing from ground frame, that is from lab frame. So if I do from lab frame, the first collision will happen between these two. Now when the first collision happens between these two, what will happen? This total velocity will become v by 2. So if this velocity is v by 2, this thing is moving with v by 2, this is moving with v. So what is the relative velocity? Relative velocity is v minus v by 2, that is v by 2. Now what is the time taken for first collision? That is L by v. After first collision, this thing is moving with speed v by 2, this is moving with speed v. So relative velocity is v by 2. So after how much time it will be colliding? It is L by v minus v by 2. Now when these three collided, now what was the total momentum initially? 2mv. Now total mass is 3m. So when these three combine, then the velocity will become 2v by 3. Now when these three combine, that velocity will become 2v by 3. This velocity is v. So what is the relative velocity? It is v minus 2v by 3. Now similarly next one will become v minus 3v by 4 and so on. I can apply for first ball. So that is nth ball. So I will be getting v minus n minus 1 into v by n. So now when I take L by v common, it will turn out to be 1 plus 2 plus 3 plus and so on till n. So which is L by v into n plus 1 by 2. Now if I observe the same thing from this frame, this frame, or sorry, from a frame where these are at rest. So I'll be observing from a frame which was moving with speed v. So if I observe from a frame which is moving with speed v, I'll be feeling all these are at rest, but this is moving with speed v. So that is how I am going to do this. Now what will happen? What is the time taken for these two collisions? L by v. Now after these two collide, the velocity will become v by 2. So what is the next collision time? It is L by v by 2. Now once these three collide, then the velocity will become v by 3. So what is the time of collision? Next collision L by v by 3, and so on. So when you do it, you will be getting the same answer. But which frame is going to be easy? Obviously this frame is going to be much easy in calculation when compared to this frame. Sometimes shifting frames helps, right? So this chapter is majorly about shifting frame only. But in the previous question, we didn't do anything. We just used our kinematic stuff majorly. But shifting our frame to center of mass frame will help at many places. Now this is a very common question. There is a spring which is at natural length, and this speed, there is a block 1 kg, this velocity is 0, and it has given some impulse, so it gained a velocity 10. Now what is the maximum compression in the spring or maximum extension in the spring? So this is going to be the question. Now for that, in ground frame, how it looks is, initially this momentum is 10, this momentum is 0. This velocity is 10 and this velocity is 0. Now what will happen? This will try to go forward. Now when it is trying to go forward, what will happen? Spring will get compressed. If spring is getting compressed, it will try to push this one this direction. It will try to push this one this direction. So what will happen? This will gain velocity this direction. This will reduce the velocity. But note that the total momentum of the system must be remaining same. Total momentum was 0 initially, now also total momentum was 10 initially, now also it is 10. So all are internal forces now. So momentum of the system can't change. Now what happened? This is moving with speed 10, this is moving with speed less than 10. So it will be obviously compressing. Now in the next moment, I have taken, this speed will become 3. Obviously it is going to still compressing, right? So spring will be trying to push it. So this speed will become 3. When this speed becomes 3, this speed will become less and it will become 7. The total momentum has to be 10. Now in the later moment, when this speed becomes 4, this speed must become 6 because the total momentum has to be 10. Now when this becomes 5, this one also will become 5. Now till now what was happening? This speed is less than this speed. So obviously compression will be happening, or the distance between them is keeping on reducing, or the spring is getting compressed. But what happened now? The relative velocity is 0. But what you know, the spring is in compressed position. So it will apply force on this block in this direction, on this block in this direction. So this speed will further increase, this speed will further decrease. So in the next moment, this speed will become 6, this speed will become 4. But what happened from here to here? From here to here, the spring has expanded because its velocity is more than 5, this velocity is less than 5. So it is expanding. So when you observe from ground frame, what is happening? From the initial situation, compression is happening, till when? Till both the speeds are remaining same. So again it is expanding from here to here. Now if you want to find what is the compression in the spring, so what you can do, there is no mechanical energy loss here. So what you can do is, you can find what was the initial kinetic energy. Initial potential energy was 0. So whatever is the total initial kinetic energy, it will be converted as this kinetic energy plus that potential energy. So you can use energy conservation between this situation and this situation to get what is the maximum compression. Now maximum extension also is going to be the same thing. Like when you go further, maximum extension also you will be going to get the same way. Now I will be trying to look the same thing from a other frame, which is center of mass frame. So what is the velocity of center of mass? Velocity of center of mass is m1 v1 plus m2 v2 by 2, which is 5. So velocity of center of mass is 5 in this direction. So when I observe from a frame which is moving with speed 5 in this direction, then I will be feeling this velocity is 5 and this velocity is 5. Now when I observe from center of mass frame, the same thing looks like this. Now what will happen? What was the initial momentum of the system? 0. Yes, in center of mass frame, initial momentum of the system must be 0, that you can see. Now what will happen? This is trying to come this way, this is trying to come this way. So when they are trying to come, what will happen? Spring will be getting compressed, so spring will try to push them, so their speeds will get reduced. So if this becomes 4, this one also will become 4. Thereafter this becomes 2, this one also will become 2, this becomes 1, this one also will become 1. Now when this gets stopped, this one also will get stopped. So this is the maximum compression situation. From center of mass frame, what I can say, whatever was the total kinetic energy, now it is totally converted to spring potential energy. So I can directly conserve energy between this situation and initial situation to get the what is the maximum extension. So in center of mass frame is going to be easy in this particular case. Thereafter what will happen? Now spring was compressed, so it will try to push them back, so they will be expanding. So in center of mass frame you can clearly see when they come back to this situation, when the spring becomes natural length, then the speed will be 5 in this direction, the speed will be 5 in this direction. So they will go further, they will stop somewhere, they will come back, their speed will become 5, they will stop, they will go, they will stop, they will come, they will stop. So you can see clear SHM in center of mass frame, but you can't see that SHM from ground frame. So in ground frame, if you want to observe from ground frame, you break it into parts. You can see it like motion of center of mass and motion about center of mass. So from ground frame, if you divide it into two parts, that is motion of center of mass and motion about center of mass. Motion of center of mass is going to be constant velocity. Motion about center of mass is going to be SHM. Right, so we'll be looking at this question. There are two blocks M1 and M2. I am applying some force F and the same amount of force but in the opposite direction here. So what is the net force on the system? Net force on the system is 0, so center of mass won't be moving. Though this mass can move, but center of mass won't be moving. Now the meaning is, if center of mass is not moving, M1 x1, if this goes by x1 and this goes by x2, then M1 x1 must be equal to M2 x2. That we have seen in river boat question also, right? Man boat question. So M1 x1 must be equal to M2 x2. Now anyway, that is not needed to solve the question here, I guess. So the question is, find the maximum extension in the spring. Now when it is going to be maximum extension, what will happen? Kinetic energy will become 0. Kinetic energy will become 0, right? Right now spring is at natural length. Now because you are applying force, what will happen? It will increase its kinetic energy, but after some time the spring force will be dominating, so it will decrease and it will come to rest at some moment. So that is the maximum extension position. Now after this, what will happen? It will try to go back. There will be SHM again. So that I am not going to discuss. Now the thing is, we need to find what is the maximum extension. So what is the work done by this force? It is F into x1. What is the work done by this force? F into x2. But what is the spring potential energy? Half into k into total extension square, which is x1 plus x2 whole square. When it is maximum extension, kinetic energy is 0. So whatever work done by these two forces must be converted as potential energy in the spring. So what is the maximum extension? 2F by k. Right? Now there is other question where I am applying unequal forces F1 and F2. Now this is not going to be so easy from ground frame. So what I will be doing, I will be observing from center of mass frame. The first thing is, I need to find what is the acceleration of center of mass. I assumed F1 is greater. So if I assume F1 is greater, acceleration of center of mass is F1 minus F2 by M1 plus M2 in this direction. So when I observe from a frame which is moving with velocity of center of mass and acceleration of center of mass, or when I observe from a frame of center of mass, what will happen? I will be feeling a pseudo force this much on this block and this much on this block. Now when I add these two, F2 plus M2 into acceleration of center of mass, or when I subtract these two, I will be getting the same thing here. This one is same as this thing. Now which I will be calling it as F. This minus this or this plus this is going to be same value. So I am going to call it as F. Now what is the thing? The thing is, this situation we have already seen. Now we know how to do this question. It is F1 into x1 plus F2 into x2 equal to half k into x1 plus x2 whole square, right? So yeah, there is some okay, fine. I was not recording these videos in order. So actually, like, maybe if I plan intro for these videos, I will be saying that example of mathematician and building on fire. Okay, so yeah, you can relate to it if you see intro, if there is intro for these videos. Building on fire. Okay, the next question goes like, two small identical discs of each of mass m lie on smooth horizontal plane. The discs are connected by light non-deformed spring of length L0 and stiffness x. At certain moment on one of the disc is set in horizontal direction perpendicular to the spring velocity V0. Find the maximum elongation in the spring in the process. If it is known, consider to be considerably less than unity. So the extension is much less than the natural length. So this was the initial question. They said like one is at rest, one is given velocity v0. Now you need to find what is the maximum extension. So both objects will be going to move in future. So I will be going to observe from center of mass frame. So from center of mass frame I will be feeling this velocity is going to be v0 by 2, this velocity is going to be v0 by 2. Momentum of the system is 0, that we know. Now what will happen when they are trying to go this way? It's not like, okay, when it is trying to go this way, when it is trying to go this way, you can clearly see the spring will be expanding. The spring will be expanding. So something is going to happen, like the expansion is going to stop only at certain position. Now that is maximum extension position. But try to understand that maximum extension position. You can see like this is going to expand. But at the maximum extension position, what does it mean by maximum extension position? The speed of this one and this one is 0. Obviously one speed is 0, then the other one also must become 0 because momentum over center of mass is 0. So if the speed is 0 and the speed is 0, that is maximum extension position. In the later moment it will be compressing back again like SHM thing, right? But this speed can't become 0 because angular momentum has to be conserved, right? And all forces are internal forces. If there are only internal forces, momentum of the system must be conserved, which was 0 initially, which was 0 finally also. Angular momentum also must be conserved, right? So this velocity can't be 0. Now what all things I have? I can say momentum has to be conserved, which I have used in the figure itself. When I shift on to center of mass frame, momentum conservation will automatically be coming into picture by itself in the figure itself. Now natural length is L0. Now the extension is x, so this length is L0 plus x by 2, this length is L0 plus x by 2. This length is L by 2, this length is L0 by 2, right? So what was the initial potential energy? 0. What was the initial kinetic energy? Half m into v0 by 2 whole square, half m into v0 by 2 whole square. So 2 times of half m into v0 by 2 whole square. This was the initial kinetic energy. That initial kinetic energy is converting as final potential energy in the spring plus final kinetic energy of both the blocks. So this is conservation of energy. Now conservation of angular momentum. Initial angular momentum is L by 2 into m into v0 by 2, 2 times, right? Both will be adding up. Now that is equal to final angular momentum this much, m into v into this distance L0 plus x by 2, but for this block, so 2 times. So these are the two equations. How many unknowns we have? X and v. So there are two equations, two unknowns. You can solve them. I am not going to solve, but you can use binomial approximation according to the given information in the question. But all you need to understand is the importance of center of mass frame and conservation laws, conservation of momentum, conservation of energy, conservation of angular momentum. Now we'll be seeing why. Okay, what is the importance of center of mass frame from energy point of view? Kinetic energy of the system will be given by half m into v1 square plus v2 square plus v3 square and so on, right? Half m, yeah. So this is velocity of the particle from ground frame. Now I can write the same thing as velocity of the particle from ground frame is nothing but velocity of center of mass plus velocity of particle in center of mass frame. Velocity of particle from ground frame is same as velocity of center of mass plus velocity of particle in center of mass frame. So this tilted dash represents whatever is representing speed of the particle, velocity of the particle in center of mass frame. This is velocity of the particle in center of mass frame. This is velocity of center of mass. This is velocity of particle in center of mass frame. Now when I expand it, it is a plus b whole square. Now I will be bringing all these vc square terms common. I will be getting half into m1 plus m2 and so on. This term. Thereafter I will be taking half m1 v1 tilted square plus half m2 v2 tilted square and so on. Now the remaining thing is this 2 will be getting cancelled. So m1 dot product, right? Either I can keep it this side or anything. When I modify it, I will be getting m1 v1 tilted plus m2 v2 tilted and so on, dot product with velocity of center of mass. Now this thing is nothing but total mass, right? So this is half into total mass into velocity of center of mass square. Now what is this look like? This looks like the same thing as this, but the only difference is instead of vector there is tilted thing. The meaning is if this is kinetic energy of the system from ground frame, this is kinetic energy of the system from center of mass frame. Kinetic energy of the system from center of mass frame. Now what about this? This is m1 v1 bar plus m2 v2 bar plus m3 v3 bar form, right? So that is total mass into velocity of center of mass. But in which frame? It is v1 in center of mass frame, v2 in center of mass frame. So totally I will be getting total mass into velocity of center of mass in center of mass frame. Total mass into velocity of center of mass in center of mass frame, which is going to be 0. So this term is going to be 0 only in center of mass frame. So that is the importance of center of mass from kinetic energy point of view if you want to see. So when you can try to see the motion like, you can try to see the energy like kinetic energy of the system, you can divide it into two parts. One is kinetic energy of the center of mass alone, that is as if the center of mass is moving like a point, the total mass is moving like a point with velocity of center of mass, plus kinetic energy with respect to center of mass. So kinetic energy of the system equal to kinetic energy of center of mass plus kinetic energy about center of mass. So this will help us to see the motion in rigid body, the motion, whatever complex motion, you can see it like motion of center of mass and motion about center of mass. From energy point of view, it helps. Even I can show from angular momentum point of view also it helps. Angular momentum of the system equal to angular momentum of center of mass and angular momentum about center of mass, right? So what we got, the result is kinetic energy of the system equal to kinetic energy of center of mass and kinetic energy about center of mass. This kinetic energy about center of mass in rigid body motion is turning out to be half IC into omega square, you must be knowing. Now when there are only two masses like collisions, that kinetic energy with respect to center of mass will turn out to be half into mu into v relative square. Mu is m1 m2 by m1 plus m2. Now I will be showing that proof if you need. If there are two masses, m1 which is moving with velocity v1 bar, m2 moving with velocity v2 bar, then the velocity of center of mass is this much. Then kinetic energy we had just have seen, kinetic energy totally equal to kinetic energy of center of mass, which is half into total mass into velocity of center of mass square, plus kinetic energy about center of mass, kinetic energy about center of mass. In the previous examples we have seen, from center of mass view, net momentum has to be 0. The meaning is if this momentum is p, this momentum also must be p. So what will be this kinetic energy? P square by 2m1. What will be this kinetic energy? P square by 2m2, where that p is momentum of the particle from center of mass frame, right? So when I do it, when I modify it, I will be getting p square by 2 times of mu form. What is mu? m1 m2 by m1 plus m2. As it is difficult to write, we will be using some mu, and we have some name called reduced mass and stuff, because it will be appearing again and again. Anyway, so momentum of the system, momentum of the particle, first particle from center of mass frame will be m1 into v1 bar minus vc bar. So when I do it, I will be getting momentum of this particle is mu into v relative. Now this is also going to help, because this also looks like very simple term like m into v. So if there are two masses which are going to collide, that is two mass collision, you can clearly see from center of mass frame this momentum will be mu into v relative, this momentum also will be mu into v relative. So if I substitute that momentum here, then I will be ending up with half into mu into v relative square. So in a collision, if I start observing a collision from center of mass frame, then what will be the momentum of this particle? Mu into v relative. What is the momentum of this particle? Mu into v relative. What is the kinetic energy of the system from ground frame? Half into mu into v relative square, right? Yeah, it looks complicated here, but you can go and check with the example what I have done with numbers. And this comes handy at many places, because if it is, especially if it is perfectly inelastic collision, what will happen? This will have some momentum, this will have some momentum, some center of mass frame. So they will be coming and they will be colliding and they will be coming to rest. The meaning is this kinetic energy plus this kinetic energy, which is half into mu into v relative square, is going to disappear as heat. So what is the kinetic energy lost in perfectly inelastic collision? That is half into mu into v relative square, that you can say directly. Now the next question. Yeah, there are two identical particles of each of mass m at a distance r0. So you are giving one velocity v0 and stuff. So it is same as spring question. Now the thing is, center of mass velocity is going to remain same, because there are two particles and all the forces are internal forces thereafter. So velocity of center of mass is not going to change. So kinetic energy of the system is kinetic energy of center of mass and kinetic energy about center of mass. This is not going to be 0. Half into total mass into velocity of center of mass square. This will be 1 by 4 mv0 square forever. So this energy you can't convert it into potential energy. You have to increase the distance between them to infinity, right? But for that you can't use this, because this will always stay there as kinetic energy only. The only thing what you can utilize is this energy, which is remaining 1 by 4 mv0 square. This energy you can utilize and you can increase the potential energy. Now this kinetic energy plus initial potential energy, if it is less than 0, then it will be bounded. If it is greater than 0, it will be unbounded. Now the importance of this question is same as previous question. In the previous question also you can see, in this question also you can see, total energy you can't kinetic energy of center of mass won't be going anywhere. In this question, velocity of center of mass is v0 by 2. So in that kinetic energy terms, the first term is never going to be 0. Kinetic energy of center of mass is never going to be 0. So you can't use that for extension in the spring there. You can't use that kinetic energy of center of mass for increasing the potential energy here. But why we never came across this one in gravitation is, this is the reason. Kinetic energy equal to kinetic energy of center of mass plus kinetic energy about center of mass. When there are two masses like sun and earth, then velocity of center of mass is m into v by m plus m. So this is half into total mass into velocity of center of mass square. When I do this, I will be getting something like this. But generally what used to happen, mass of sun is much greater than mass of earth. So this term used to be going to be 0. So the total kinetic energy is almost staying with about center of mass term. So that is the reason we never came across this, because this term used to be 0 for us generally. But if it is not 0, then you can't use that particular energy for increasing in potential energy. Now the next question goes like, there is 2 kg which is moving with speed 6, another one is 4 kg which is moving with 2. So you need to find, it is perfectly elastic collision. So maximum possible deflection of 2 kg. Now from ground frame, this is how it looks. They said like this is moving with 6, this is moving with 2. And maximum deflection you have to find. So the meaning is it is not head on, it can be any other case, any case, but you need to see what is the maximum possible deflection. Now for that, what I am going to do is, I am going to shift my frame into center of mass. That is this momentum plus this momentum by total mass. This is velocity of center of mass. When I observe the same thing from center of mass frame, how it looks is this way. So when I am observing from a frame which is moving with 10 by 3, I will be feeling this is moving with 4 by 3, this is moving with 8 by 3. Now you can see total moment, this momentum is 16 by 3, this momentum is 16 by 3. Momentum of the system in center of mass frame has to be 0. Now we have already seen in perfectly elastic collision, the only way they can have momentum conservation and energy conservation is by having the same speeds. The meaning is, after collision also the speed must be 4 by 3 only. In head on, what we have seen, if it is coming with 6 and this is coming with 3, then this used to go with 6 and this used to go with 3. Now the same thing will happen here. This speed has to be 4 by 3 forever, this speed has to be 8 by 3 forever. So after collision there is a chance like, if this is going with 4 by 3 in this direction, this will go with 8 by 3 in this direction. If this goes with 4 by 3 in this direction, then this will go with 8 by 3 in this direction. But net momentum has to be 0. So some direction. But whatever it is, this speed will be 4 by 3, this speed will be 8 by 3 from center of mass frame. Now if I want to observe this velocity I can look it into two parts. One is velocity of center of mass and velocity about center of mass. What is the velocity of this one about center of mass? It is 8 by 3. But what is the velocity of center of mass? It is constant in this particular question, which is 10 by 3. So if I want to find the net velocity of this one, that is going to be velocity of center of mass 10 by 3 in horizontal direction. For this I need to add velocity about center of mass. Velocity about center of mass is 8 by 3. The meaning is, it can be in any direction. It can be this direction or this direction or this direction. So it can be any direction. But you can see 8 by 3 is less than 10 by 3. So I have taken the radius less than blue color line. So velocity of center of mass and velocity about center of mass. But if velocity about center of mass is along this direction, then you can see the deflection is minimum. The deflection is not maximum. The deflection is going to be less than maximum. So for the deflection to be maximum, it has to be tangent. That will happen when this is going to be this direction. So when velocity about center of mass is going to be this direction, then that is going to be the maximum deflection case. So what is the maximum deflection? Tan theta equal to 8 by 3 by 10 by 3. So you will be getting the required answer. Now this question is going to be pretty simple from center of mass frame, but not from ground frame. Now there is other question here, you can try by yourself, which is from center of mass frame as well as from ground frame. Then you will understand the importance. Now the next question goes like, is center of mass and center of gravity same definition, or like when it is going to be same definition? So center of mass is defined as m1 r1 plus m2 r2 plus m3 r3 and so on equal to total mass times of position vector of center of mass. So this is the definition. Now what is the definition of center of gravity? Center of gravity is where we feel like the total weight is getting acted, or where we will be feeling like the total weight is getting acted. That is, the torque due to the weight will be same, right? Torque due to, let me say, there are many particles. So torque because of the weight of first particle is r1 bar cross m1 into g bar. Torque due to second one is this much, third one is this much. Now where the total weight, where the total force has to act so that the torque will remain same. So that's the definition of center of gravity, right? Now obviously you can see it is going to be complicated. Now let me see what will happen if g1 equal to g2 equal to g3. which is G. So when I do that modification, you can see everything. So finally you can see like equations are turning out to be same, that is center of mass is going to be same as center of gravity. The meaning is when only this happens, when will this happen? If you see here, that will happen for small objects, right? So when the objects are large, what will happen? Different particles will be experiencing different acceleration due to gravity. But in general, whatever we will be dealing, they will be like experiencing almost the same gravity. So we will be saying like center of mass and center of gravity are almost the same things, but actually not. So the next question goes like, a ball is thrown against a wall of very long triangular room which has vertex and angle theta. The initial direction of the ball is parallel to the angle bisector. How many elastic bounces does the ball make? Now this question is like this. Now let me say there is a light ray. There is a light ray which is coming and hitting this mirror. Now angle of incidence is equal to angle of reflection. Now after this it will be hitting here and it will be going this way. Now what I am going to do is, whenever light is hitting, like I'll be inverting the mirror. Now when I invert this mirror thing, it will come this way, and this ray, now this red color thing is getting inverted and getting appeared here. This blue color thing is getting inverted and getting appeared here. Now what you can see here, you can see the figure looks like, when I invert this figure, the figure looks like as if this ray is going without any deviation. Now after hitting here, that is after hitting here, it is going this way. Now how it looks here? Now again, after hitting here, now I am going to invert it this way. So if I invert it this way, this ray will go like as if undeviated, and this black color thing will appear here, right? Now how we will be getting this structure? Is you invert it this way and invert it this way. So 90 degrees, when you do that, you will be getting this figure. Or else the crux of the question is, instead of drawing the reflected ray, you can just invert the mirrors. Now why we are talking about light and mirrors? Because perfectly inelastic collision works the same way as light, right? So now you can do the same thing. Now I have done for 60 degrees, they have given for theta, so you can try by yourself. So if it is 60 degrees, now the initial mirrors looked like this. So the ray was coming. Once it hits, what we need to do? We need to rotate the mirror about this. So the mirror will turn to be this red color. After hitting this mirror, then what you can do? You can keep the ray undeviated, but you can rotate the mirrors. Now when it hits here, then what you can do? You can keep the ray as it is, but you can rotate the mirror. Now similarly, again when it hits here, you can rotate the mirror. But you can see here, now it is not going to hit any part of the mirror. That is how many collisions happened? 1, 2, 3. 3 collisions happened. Now that you could have done by drawing figure like reflection here, and going something like that. But that is going to be complicated in this case when you concentrate on the ray. So instead of concentrating on the ray, keep the ray as it is and concentrate on rotating mirrors. Alright. So the next question is center of mass. So there is a disc and you will be removing like some part of it, right? So this is a very common question. You need to find what is the center of mass of the remaining thing. Now basically all these questions say this: there was some disc, now you are removing this part, you need to find what is the center of mass of this one. So how you need to, whatever be this question, you have to see this way: full disc is equal to this part plus this part. Now if this mass is m, this is going to be 4m, because if this area is here, this area will be 4a. Now if this mass is m, this mass is going to be 4m, so this is going to be 3m, because 3m plus m has to be 4m. This is how I do it. Now this m into r, this m into position of center of mass equal to this m into its position of center of mass plus this m into this position of center of mass. Now I know this is symmetrical object, so this total mass is 4m into position of center of mass 0. Again, the other thing, you know, this is symmetrical axis, so center of mass must lie along this axis, so I will be concentrating only on the x coordinate. So this total mass into this x coordinate of center of mass, which is 0, equal to this mass into this x coordinate, which I have to find, plus I have taken this as origin, so this mass into this x coordinate is how much? R by, this is r by 2, m into r by 2. So what I will be getting from there? X equal to minus r by 6. Yes, it makes sense because this center of mass will be somewhere here, negative r by 6. So this m into this center of mass position equal to this m into this center of mass position plus this m into this center of mass position. Right? Okay, this is a regular question. Yeah, r by 2 distance, and there is other perspective of seeing it. Yeah, you can understand like why it is r by 2.